Here I am across the room. I got two lamps. They look like little Pixar lamps. Boink, boink, boink. And they are shooting serious light down on spinaccio, better known as spinach. And the spinach leaves, hopefully, I put a little water on them, keep them nice and happy. And we want these to be supercharged, photosynthetic ready. And they're starting to photosynthesize right now. So when I cut the little discs out of them, photosynthesis is supercharged. So we can have these guys do what we want them to do. Here's my setup in the other room. I got little light, 800 lumens, and big light, more lumens. And then I have, of course, I got a little distilled water right here. The tape fell off, but it's distilled water. This is my 0.2% bicarbonate solution that I just put sodium bicarbonate in, and here's my slightly soapy water. And then here I have my syringes and whatnot. I got my white paper, I got some droppers ready to go to stir, and of course, everyone's favorite, single hole punches! And then clear cups, clear cups, clear cups. All right, so here's my massacre station where I'm taking lovely leaves that I've placed in the light for a while, and I'm taking my single hole punch and I'm punching holes, trying not to get the big vein areas. And I'm getting a bunch of leaf discs on my piece of paper here. Yay. It's therapeutic, mutilating leaves. Alright, so I have two clear cups, one that says carbon dioxide, the other one says no carbon dioxide. This one has bicarbonate solution, this is distilled water. This is 0.2%, which is 2 grams in 1,000 milliliters of sodium bicarbonate. I then have soapy water, which is right here. The soapy water is a wetting agent, and I'm going to add a few drops to each. And you add the same amount of drops to both, and we'll mix both of those solutions up. And then you're going to load up a syringe with 10 of these discs. One without scrunching them. 2, 3, 4, 5. 6, 7, 8, 9, and 10. Okay. After you do that, you go ahead, you don't want to, you tap them down a little bit because you don't want to kill them and scrunch them. And then now they're in a syringe. Now you're going to suck that up with a little bit of the solution and swirl them. Okay? You're going to get rid of the air spaces. And then what you're going to do is you're going to create a vacuum by pulling down on this and swirling. Now, our whole goal in this component, as you're swirling, is when you create that vacuum, you want, due to the fact that there's soap in there, you want your floaters to become sinkers, and that soap is decreasing the hydrogen bonding between water molecules on the stoma. And notice they used to be floating, now they're wanting to sink a little bit. And the reason why that's happening is because a vacuum, which is me giving myself a thumb hickey, creating a vacuum and swirling, is
getting all the gas out of the leaf. And then that gas is being replaced by liquid. And then the floaters become sinkers. So I'm going to do this one more time, and then I'm going to have all of them sinking. And then you're going to do that with the carbon dioxide water, but also with the distilled water. And they're all sunk, which is what you want. Okay? Now, I'm just going to do this with the carbon dioxide. You're going to use the same procedure for both cups. So this is the moment when you want all of the discs to go into the solution. And this is inherently where kids get water all over their pants. And if you notice, all of my discs are now dropped to the bottom of this cup. At this time, and I would have 10 discs also at the bottom of the cup with the distilled water, I'm going to place my cup in a light source. As you have this in a light source, we're going to time. This is when we start timing. And I'm going to swirl. And by swirling, sometimes the disc gets stuck to the bottom. So swirling kind of decreases how much they're swirling. I have a video of this, and basically what we're trying to do is we're trying to watch. Hey, are they going to float? Look at the one. Yay! Go to the top. You can do it. Look at it go. Yay! And now the sinker has become a floater. And as we do this technique, I usually have kids swirl because sometimes they get stuck on the sides or get stuck at the bottom. And then we count the number that are floating and the number that are sinking after the swirl. So if you notice right now, I have 2 that are floating at the top. See those 2 kind of swirling around at the top? And the rest are still at the bottom. The reason why they start to float, as we all know, is because after I sucked in all of that stuff, and we have liquid inside the leaf material, gas replaces the liquid. And the gas that obviously that's getting produced during photosynthesis is molecular oxygen. And then that gas that's now in the leaf makes it buoyant. So as soon as that gas gets to a point where the sinkers become floaters, we know that photosynthesis has occurred enough for those discs that are all this. Here's another one going. Look at them go. Look at them go. You can make it. You can make it. Yay! And now, look, we have 4 floaters. And you just record time. How many floaters do we have? And then it's kind of, ooh, there it goes. You can name each one that starts to float. And it makes you thoroughly happy when they actually do float. Ooh, yay. It's not a terrible, it's it's not one of the higher tech labs that you could do, but watching them float, oh, look at the ones ready to go. You can do it. We will call it Henry. Henry. The question is it a rule or a Podusca? Ooh! 2 of them, both. A Podusca and a rule. What about a Tavens? I got another Henry. Come on. There's a Henry, another Henry at the bottom. You can do it. Come on. Come on, Henry. Sometimes if you're nice to them, they start to float a little bit faster. You can do it, Henry. I believe in you. Even though you didn't take any data for the 2-minute, I still believe in you. You can do it, Henry. Come on. Yes. It's ready to go. Come on. Yes. 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 Henry, you got it. All the way to the top. You are now officially a floater. Yay, look at him go. There he is. Kablap. He's at the top. And then we just have one that is completely sunk. Sometimes when kids do this lab, they destroy the discs and they mutilate them so much that they never float. And that's kind of sad. That's the reason why we use ET50, so the effective time when 50% of the disc is floated, so that 50% of 10 is 5, because some of them just die and they never float. And that is the highly sophisticated sinker floater photosynthesis lab. Kind of fun, but not as sciencey as the dye reduction technique. So even after a couple of hours, here we have the carbon dioxide group. They're all floating. And here we have no carbon dioxide, and they're all still sunk. Still, I had this guy in the light for a really long time too. Just to prove to you that, gee, carbon dioxide is needed for photosynthesis. Nothing more enjoyable than making a video on a Friday about floaters and sinkers. My life is so awesome.